Hello, welcome back. This is the sixth problem for the regular season of the MIT Integration Bee 2025. I suggest that you pause this video first and try to solve this on your own. As I've mentioned in previous videos, questions here are meant to be answered in 2 minutes. If you're ready, let's discuss my solution. Now this one is not a usual function that is discussed in calculus classes. This is what we call the maximum function. So basically it outputs the maximum value of the inputs. So in this case, the inputs are the functions x, x squared, and x cubed. Now this is not a fixed function. You cannot choose just x, x squared, and x cubed at all points. Otherwise, this just simplifies to just one single function. One common misconception of people is that just because you have here a cube, a power that is higher than the other powers, then they conclude that this is apparently just x cubed. And that's just wrong. To properly analyze this one, we analyze the behavior of the functions on the limits of integration. Note that x, x squared, and x cubed are all powers of x. Now if x is less than 0, let's call this negative 2 to 0, the value of x and x cubed are negative, right? Because, well, that's negative times negative times negative, that's still a negative number. So this one is less than 0, and this one's less than 0. So definitely, regardless of the value of x, x squared will always be the maximum value in this interval. Therefore, the maximum is equal to x squared if x is in 0 to 2, right? Negative, what am I saying? That's negative 2 to 0, right? Now, if x is positive, then the value of x, x squared, and x cubed is not necessarily or immediately obvious, unlike when it's negative. In fact, we have to actually split still the positive range into the interval where x is from 0 to 1 and the other one is from 1 onwards. Why? Because when you raise a number that is between 0 and 1 to a power higher than 1, its value actually diminishes. For example, 1/2 to the 1 is 1/2, 1/2 squared is 1/4, and 1/2 cubed is 1/8. The value diminishes as you increase the power. So from 0 to 1, the highest value of the function is, or among these three functions, the highest value will always be x. So it will always be this one. You get it? So from 0 to 1, the maximum value is x. Meanwhile, from 1 onwards, if you raise the value or the power, its value increases. For example, let's just say 2. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. So the value increases as you increase the power. So from 1 to 2, the maximum value is actually x cubed. So what does this tell us? It tells us that we can split a function into these three piecewise functions, x squared x and x cubed, if x element of 1 to 2. Which goes to say that in evaluating or to evaluate the function, we write it as a sum of three definite integrals. So that's negative 2 to 0. The value is x squared, right? And then from 0 to 1, the value is this one, x dx. And then from 1 to 2, the value is x cubed. Understood? Okay. So these ones are just polynomial functions, so should be easy to evaluate. So x cubed over 3 from negative 2 to 0, x squared over 2 from 0 to 1, plus x to the 4th over 4 from 1 to 2. And in evaluating this, we get 8 over 3. So this one is, negative of negative 8 over 3. That's why it's positive 8 over 3. And the other one is 1 squared over 2 minus 0 squared. So that's 1/2. Then lastly, that's 2 to the 4th, 16 minus 1 to the 4th, 1 over 4. This is 8 over 3 plus 1/2 plus 15 over 4. To more easily evaluate this, write as a common fraction. The LCD, the least common denominator, is 12. So this one is 24 plus 6 plus 45. Is my arithmetic right? Sorry, this is 32. Oops, this is 8 times 4, 32. So 32 plus 6 is 38, plus 45 is 83. So the answer is 83 over 12. And that's our final answer. So again, what we did here, just to recap, what we did here is we examined the value of the three functions on several intervals to conclude what the value of the maximum is for each of those three intervals. And that's a general solution when you encounter problems like this max function. The same is true when you deal with the min function. So you just have to examine what is the minimum value on several intervals. That's basically just splitting the integral into piecewise functions. Okay? And often, I think always, when you evaluate this type of functions, it always has to be a definite integral. Otherwise, it's just a vague integral, which is difficult, if not impossible, to generalize. Okay? So that's it for this video. Thank you for watching, and if you have any comments, clarifications, suggestions, or violent reactions, just let me know in the comments. Thank you for watching, and see you on the next one. Bye-bye.